In this lab class, we are going to see the experiment BJT based RC phase shift oscillator. Normally we know that oscillator, two types of oscillator, that is LC and RC. Here we are going to see RC phase shift oscillators. So aim is to produce a sinusoidal waveform, and you have to verify theoretical and practical frequency. So practically we have to find the frequency from the waveform in the CRO, and then we have to verify using the formula, right? So apparatus circuit, as usual, transistor, that is a voltage divider bias, right? Voltage divider bias, that is an voltage divider input, that is two resistors, right? The circuit is used here. Transistor and resistors, a single RPS, and capacitors for coupling capacitors, and there's a breadboard for connecting circuit and connecting wires, and you need CRO for this experiment, right? And this is the circuit for this phase shift RC phase shift oscillator. So RC, this one is this transistor, this 470 and 12 kilo ohm represents the voltage divider input. It produces input to the bias, and RC and RE, CE, and coupling capacitors, 10 microfarad we have used. This one represents the voltage divider circuit, and this coupling capacitors, that is an output of this transistor is taken as a feedback and feed to the feedback circuit. Here we are using 3 RC networks, one RC network on 330 ohm and 0.1 microfarad. It produces a 60-degree phase shift, and another RC network produces another 60-degree phase shift. Another will produce another 60-degree phase shift, right? So transistor will produce another 18-degree phase shift. So totally 360-degree phase shift will be obtained using this RC phase shift oscillator. That is a Barkhausen criteria, right? So model waveform, it will produce, this circuit will produce a sinusoidal waveform. That is, we are giving a DC input. Based on the DC input, it will produce a sinusoidal output. Okay. So tabulation part. So from the practical, that is from CRO, you have to measure the amplitude and time period, and have to measure the frequency, that is 1 by T, right? Sorry, frequency. Okay. So from practical time period, you have to measure the theoretical frequency and time period. Okay. So design, we had already designed based on the input frequency, that is 2 kilohertz, right? So for by assuming frequency is 2 kilohertz and keeping capacitor 0.1 microfarad, so we had choose the resistor as 318 ohm. That is an so here resistors 330, approximately 330 ohm, nearby resistance 330 ohm for design, right? Okay. So now we will move into the circuit. So as per the circuit diagram, this is an BJT transistor, and here an RPS is used, an RPS supply to resistors, that is in VCC, from VCC to resistors given to the base and collector, and then coupling capacitors. This capacitor, one part, that is one capacitor inductor produces 160-degree phase shift. Another capacitor resistor produces another 60-degree phase shift. Another capacitor and resistor produces another 60-degree. So this comprises feedback network. This feedback network is connected with one coupling capacitor. Another, it is connected with another coupling capacitor. Okay, right. And output is, we are taking the output from the collector, and we are going to see the output in the CRO. Okay, right. So in this CRO, two channels are there. This one is a channel 1 and this is channel 2. So Suppose if we had connected in channel 1 means we have to keep adjust the value, that is just like this. This is an voltage per division, that is an, and this is a time that is a time factor, time division, right, for measuring amplitude and there is an amplitude and time period. For measuring amplitude we have to use voltage divisions. For measuring time period we have to use this time base, right? So now we will switch on the circuit. Initially it was 0 volt. See, when I am increasing the volt up to when I am increasing the voltage up to 12, so DC, when I am giving the DC input to the circuit, it start oscillating. When the 12 volt, when 10 approximately about 10 volt it reaches, what will happen? It will produce a sinusoidal waveform, right? So we had given the DC input. This DC input is given to the circuit. So in the feedback network, it is a feedback network. Again, the feedback is given to the transistor circuit. So it is continuously moving and it produces a sinusoidal waveform. Okay. So now we will measure the waveform. How we are going to measure the sinusoidal waveform? Here we will adjust up to this. First we will measure the if we put ground means it will become center. Now we will measure the time period. First we will measure the amplitude. Amplitude means that is a voltage, that is this one, this positive peak and negative peak. If we want to measure positive and negative peak means it is VPP totally, but here it is a sinusoidal waveform, both the positive and negative are equal, so we can measure 1/2, right? So 1/2 means we will measure the value. This is an 1. We can move based on our requirement like this. Okay. So 1, 2. Here each division each one having 2 divisions, right? So 2, 4, 2, 4. So 1, 2, 2.4. So 2.4. This value is 2.4. This one is an 1, 2, and here 2 divisions for 2.4. So 2.4. This is an amplitude. So amplitude factor. This is an voltage. Here it is an 1. So 2.4 into 1. So the value. So practical value here it is an amplitude 2.4 into 1. Please note that whether it is voltage also available, millivolt also available. It is an volt. Please listen here. This is volt. So 2.4 into 1 volt equal to 2.4 volt. Right. So now we will measure the amplitude. Time period. So time period is nothing but one full cycle. Just based on a requirement, one full cycle. One full cycle means it will starts from here. It is one full positive and one negative. So from up to this is one full cycle. So how many blocks? 2. So 2, only 2. Sharp, it is 2. 2 into, we will see the time division. 2 into 0.2. So 0.2, here it is milliseconds. So 2 into 0.2 milliseconds. 2 into 0.2 milliseconds. Like this only you have to take the reading, write the reading. That is 2 into 0.2 milliseconds. So, okay, right. That's all. That's all about the experiment. So when you are reducing the voltage, it will automatically move to a DC, that is a straight line, right? When you are giving the input voltage only, it starts to oscillate. That is, I am increasing to, when it reaches approximately 10 to 11, it starts to increase. That is a sinusoidal waveform. Okay, right. So for switching of the RPS, you have to make it to 0 and then you have to switch off. Right. Thank you.